Right, hello, my name's Simon Lee. Today I'm going to talk about how we built the image data repository, or the IDR. So as you've heard from other talks, the image data repository is a public resource for storing and managing large high throughput screens and other data sets. We've currently got something like 40 terabytes raw data and nearly 3 million images. And one of the main drivers behind it is, as well as making data available, is to provide people the ability to start querying this massive amount of data and comparing different data sets and obtaining more information that we didn't previously know. So I'll quickly take you through the how we first developed the IDR. So first thing, of course, is to get hold of the data. That pretty much involves going out to different groups, soliciting data sets, and so on. After that, we need somewhere to store the data. So went out to buy some disks and servers. Next thing, we install OMERO. The IDR is built around OMERO. And for our development setup, we actually use Docker, which I'll talk about a bit more later. Once we had the OMERO server set up, obviously we wanted to set up the public web interface on it. So again, this was fairly standard stuff. It's all in the documentation. And then we start to get to the interesting stage. So first of all, we started importing data. Then we sort of discovered actually there's quite a few bugs. So one of the reasons for this is that the data sets we're dealing with were sort of a lot larger than we normally handle. And there was some new sort of formats that we've been dealing with. After that, we then discovered some bugs in our hardware. That was mostly configuration, but not entirely. After that, we imported a bit more data. Then we discovered more bugs and imported more data and discovered more bugs, and so on. So I'll pretty much take you through a sort of timeline on how we developed IDR now. So around about August 2015, we first had a hardware delivered. So at the moment we've got two sort of file servers, which are in front of a 450 terabyte storage array. After taking into account redundancy, that's roughly 300 terabytes of usable storage. And in addition to that, we've got 6 compute servers. So each of these compute servers has 28 physical cores, so 56 if you include hyperthreading, and 256 gig of RAM. You can see the details on this slide if you're interested. In terms of the actual storage platform, we primarily went with GPFS, or as it's now known, IBM Spectrum scale. One of the main reasons for going with GPFS is that it's used in our department, the School of Life Sciences. So in theory, it would integrate with the existing storage systems. As you may probably already know, it's a parallel distributed file system, which means multiple nodes can access it. And for the scale of data we're dealing with, so on the order of 40 terabytes, that's actually quite useful, but realistically, you don't want a single server to be a bottleneck. The downside of using GPFS is that it takes a lot of tuning. So although it's very powerful, you really need to customize it for the exact use case. I mentioned for our initial mail server, we were using Docker. So this is how we set up our 6 compute servers. So we had two of them were set up as Docker servers, our production and development. And then we had 4 other servers, which we would eventually use for sort of feature analysis and other computational work. All these servers run in CentOS 7, and we're using the upstream Docker. So if you go to the Docker website, you can see all the instructions and how to install it. So our hardware was delivered in August. In September, we started installing everything. So you've probably heard a fair bit about Docker from some other talks. So I'll just mention that at the time we had a Docker image, which allowed us to run a OMERO server with essentially one command. So there's 2 commands here. The first command is obviously to install Docker. The second command, docker run -v/IDR, essentially means mount this data share inside the Docker container. Then you run it, and it just works. There's no configuration required, nothing else, it just ran. One thing to note, though, is that I wouldn't recommend you using this image right now, since this was a very early image while we were still experimenting with Docker. If you go to Docker Hub, look at the open microscopy organization, you'll see some more modern images. and we're continuing to do work on this. So as I said, we got our server running in a few minutes. So the next thing is starting importing some of this 40 terabytes of data. I'm not going to go into too much detail because there's a separate talk on it. Follow the link in this presentation. But essentially, there's in OMERO, we've built a lot of extra options into the import function command, which lets you optimize how the data is imported. So, for example, you can disable checksumming, so you don't have to scan the data multiple times. And then there's in-place imports, which again, you can see that see the extensive import talk for more details. A couple of slides ago, I pointed out that we had two sort of Docker servers, production and development. So this is just a layout of how we were actually using Docker in the production server. So we had Docker running on the system. Then under that, we had four separate OMERO servers running on Docker. The reason for that was that some of the data sets we're dealing with were very large, very complicated. There was a lot of bugs, and we didn't want to be blocked on them. So by splitting splitting the data sets up into four different servers, we were able to work on them in parallel. So the first server were all the data sets that went in straight away, and the other three data sets were the ones that caused us a bit more problems. And then in front of all that, we had Nginx running as a proxy. So the Docker server was all in our internal network. Nginx was running on an externally facing server and proxying through to all four servers. The downside of this layout became clear later. So as you're probably aware, OMERO doesn't have a good way of federation as it exists in OMERO. And so while this was fine for development, converting it all into a single OMERO server actually ended up causing us quite a few problems later. So this is something to bear in mind if you want to try and do something similar. Anyway, so bear in mind, we had the hardware in August. September, we installed OMERO, started importing data. And at the start of October, so barely a month later, we actually had our first launch of the IDR at the EMBL Seeing is Believing conference. So this was a fully working public demonstration of the IDR. We had something like 10 data sets in. You could click around, they were all imported. At the time, it was a bit flaky. It occasionally crashed. Well, I say occasionally, more like every day it crashed. But at least it was proof of concept. And bear in mind, this was roughly a month's work. So that was our development system. Next, we had to move it into production. So we kind of took a slightly different process to deploy in production, which I'll take you through. The first thing is we decided to embrace Ansible, something called Ansible, which is a configuration management system. I'll talk about that a bit later. The second thing to mention is that our final deployment environment was going to be on something called OpenStack. So for those of you who are unaware, OpenStack is essentially an open source cloud platform. So it's something like, say, VMware or Amazon Cloud. The reason we chose that was because the final home of the IDR would be down at the EBI. They're running a cloud resource based on OpenStack. And we thought by mirroring that environment, it would make our life a bit more easier. It would make testing a bit easier. So as I said, we had to our aim would be to set this up in Dundee on our own cloud and then copy it down to the EBI. Once we've done that, we then had to get the performance tuning. So I've already mentioned our system was quite unstable during the development period. Performance tuning would be all about how we fix that. So I'm not going to go into too much detail about configuration management. There's lots on the web. There's lots those tutorials on the website, on the internet. I'll provide some links to the main configuration management systems. But essentially, you can think of it as a systematic way of setting up and configuring your servers, and that's often embodied in the sort of catchphrase infrastructure as code. But what does that actually mean? Well, if you think about writing, say, a script to analyze some data, initially you might start by just trying out different commands at the command line. Eventually, you decide you want to reproduce it, so you put it into a script and save it. After a while, you decide it needs to be documented, so to add some comments. And eventually, you decide you want to modify the script but you like to keep track of what's changed, so then use a version control system. And the idea of config management is to pretty much do the same for how you configure servers. So you have we'd have a specification file which says how each server should be configured. That can be checked into version control, so you can track all modifications. And because of the way it's designed, it actually acts as a pretty good documentation of what you've done. So what can you do for OMERO? One of the primary reasons when we decided to move to a config management system was that it allows us to open source our infrastructure. So if there's a GitHub repository linked here, openmicroscopy/infrastructure. We're still doing work on it, but in principle, you could go there, run a few commands, and you'd be able to replicate most of our servers in the OME. So not just necessarily our production servers, but eventually all of our sort of development infrastructure. So for example, a Jenkins continuous integration systems. The other things, even if you're just interested in production OMERO systems, this takes care of a lot of our documentation. So if you've ever had to set up your own server, you know it's quite complicated. There's a lot of dependencies. There's a lot of configuration, and config management can help take care of that for you. Anyway, so coming back to the actual process of setting up the IDR in production. So November, we started to set up OpenStack. The main problem with OpenStack is, as you can imagine, setting up a cloud platform is not easy. It was a lot of work. But we got it working, and the next question we face is, how do we actually deploy OMERO on it? So during development, we'd made heavy use of Docker, essentially running OMERO in a Docker container. What we could have done was basically install Docker on our virtual machines, and then we'd have almost the same setup. So the advantage of that is it's really easy to deploy OMERO. You saw from earlier, it's pretty much one command. It's easy to upgrade because you just replace a Docker container. The big downside is it's another layer of infrastructure to debug. And I bring that up with reference to our systems because when we first received the hardware, we had a lot of configuration problems. Eventually, we tracked it down after roughly a year to a storage configuration bug. But up to that time, we'd been seeing sort of unexplained freezes, and we had to sort of debug all that ourselves. So the take-home message is, if you're going to think of setting up a system like this, if you've got a reliable IT department or you've got some existing infrastructure that they take care of, whether that's Docker or virtual machines, you should definitely take advantage of it. If you are setting it all up yourself, then think carefully about how much infrastructure you want to manage. Anyway, so then December and Christmas came. January, we continued working on this. And finally, February, we managed to get OMERO working on OpenStack with Ansible. So this is just a quick snippet of what our Ansible sort of file looks like. Essentially, on the top right in that text box, I'm saying install OMERO server on this local machine and set a Postgres database. After that, you basically clone an OpenMicroscopy infrastructure repo and then run a command, Ansible playbook, omero.yml. And that leave it to run for a few minutes, and that gave us a fully working OMERO server on a virtual machine. So one thing to note is we've got a utility called OMEGO that's linked from this page. That's a tool we use internally for sort of installing and upgrading our OMERO servers. We're hoping to have this ready for use by the community in the near future, but it saves a lot of time, especially in our continuous integration process where we're deploying OMERO pretty much every day. So at this stage, we've more or less got Ansible, OpenStack, and OMERO kind of working. So in parallel with that, we now needed to get our data from Dundee down to Cambridge. With a modern internet, you think that would be quite trivial, just copy it across the internet, don't you? It actually wasn't. In the end, we resorted to two methods. So some of our data was transferred using something called Aspera, which is essentially FTP on steroids. The rest of it was sent by good old SneakerNet, so FedEx. After that, we started to think about making our OMERO server a bit more robust. So one of the obvious things is to split up the different systems running on this single server. So initially, we had OMERO, Postgres, Nginx, and everything else running all on the same VM. We then split that up into 3 separate virtual machines. And again, with using Ansible, we were able to set this up so Ansible would log into OpenStack Cloud, create 3 VMs for us, install Postgres on one, OMERO on another, on the front end, Nginx on the third, link it all together, and it all worked. So in that text box, you can pretty much see all the only commands I had to run. Essentially, that says set up your credentials for logging to OpenStack over the command line, and then run this playbook. So this is just a screenshot of what OpenStack looks like in practice. So this is the network overview. And what this shows is at the moment, there's a router, there's an external network, which is the internet, and there's an internal network. So there's no virtual machines here. And that screenshot of the term, is just an example of what Ansible looks like when it runs. So I'll come back to it later. But in the meantime, we had this working at Dundee. So the next thing is, what do we need to do to get this down to the EBI? I've said one of the reasons we set up OpenStack in Dundee was to mirror the final deployment environment as much as possible. And the use of Ansible and config management essentially made that almost trivial to do in terms of the actual OMERO server. So this is one of the configuration files that we had to modify. The bits highlighted in yellow are essentially what we had to change. So essentially what this says is we're using the EBI cloud instead of the University of Dundee cloud. They're set up slightly differently, so there's different parameters. And the other thing down here is to say the storage location at EBI is different from the storage location at Dundee. So they're both NFS mounts, but the servers are different. And apart from that, that's pretty much all we had to change to get a multi-node OMERO server running at the EBI. So now it's all running. Next thing is do some bit of production tuning. The big problem with IDR to begin with was that loading screens is slow. So these screens are several gigabytes in each, and each of them consists of several thousands of files, which means potentially bioformats has to load several thousand files each time you access the screen. On the client side, it's also slow because, well, as you can imagine, if you want to load a 384 well plate, that's 384 HTTP requests for images, plus all the JavaScript and HTML and CSS and so on. But there was one thing which we could use to our advantage, was that, at least to begin with, it's read-only and web-only access. So what do we do for production tuning? The first thing is something called the bioformats cache. This is something that's been built into bioformats OMERO since 5.1. And the idea is that when you open an image with bioformats, some of the state information is cached, and that speeds up future access. On the front end Nginx, we implemented very aggressive caching. And on the clients, we did a bit to optimize the HTTP protocol, which I'll come on to. So for the Nginx caching, we pre-warm the cache with all thumbnails, so that's roughly 3 million, and all the metadata for screens, plates, and datasets. And in addition to that, we cached all the images and the image metadata in the first request. So the idea was, if you went straight to the IDR and loaded the screen, that should come up fairly quickly. If you then went to load an image, the first time someone loaded that image, it might be quite slow, but on subsequent times, it should all be cached. We also did a bit of production tuning behind the scenes. So there's different ways of managing sessions in Web and Django. We actually implemented something called Redis. It's something we're still experimenting with. It's in the docs, and as soon as it's ready, we'll obviously let everyone know. And the client-side speed that I mentioned was to use something called HTTP2. So this is a new version of HTTP. It's been out for about a year or so. And it optimizes the HTTP protocol by allowing you to bundle requests. So instead of making 384 separate requests for images, you can sort of bundle them all up into one, and that streamlines the data transfer. So this is another screenshot of the OpenStack interface after the IDR has been deployed. Roughly, it takes the amount of time that this talk has taken so far since the first screenshot, so roughly 5 or 6 minutes. And what you can see now is that it's created 3 virtual machines, and the answerable command in the terminal is exited. So bear in mind, this is all from a single command, and this is exactly how we deployed the final IDR demo, which is live now. So I've provided a few links to some of the resources I've mentioned. As I say, the Ansible playbooks and Docker images are still under development, but you're very welcome to have a look at them. And of course, there's the image data repository. So what next? This partly comes down to what you want as a community. So obviously, we continue to work on the IDR, but a lot of the tools we've developed, so the infrastructure, config management repo, Docker, and Amigo, these are all things we'd like to modify so they can be used by the community. But as always, we have to deal with several priorities. So if this is something you're particularly interested in, it'd be nice to hear from you either on the mailing lists or say on the forums or whatever. And finally, thanks to Jason Swedlow for running the OME and our funders.